Welcome back to the shrine, where we breathe new life to the hand-me-downs of the industry. Today, short project, basically. This is one of the cylinder heads I've been working on. You've seen it many times. There's a couple other videos related to measurement and just analyzing it. And here's one that I cut in half to be able to scan it properly. There are some internal cavities that the scanner is not going to pick up first time, so I sacrificed this one. They are not the same, they're similar, but they're not exactly the same. So one of the issues was to figure out the exact position of this plane here. This is where the spring, the valve spring, is going to rest. So here's a typical valve spring, and this is where the valve spring would rest, like so. There's supposed to be a hardened washer underneath here, and that's how it's done. So you can see in one of those previous videos I measured the exact angle of the intake and the exhaust valves relative to the bottom plane. So that gave me a real precise measurement of where that axis is, how it crosses relative to the combustion chamber, relative to the camshaft axis. But one thing I didn't know, where is this plane here, relative to the universe of the cylinder head. So this plane here, or this plane. So basically there's no measurement reference to measure it. You can see that these planes here are tilted relative to this and relative to that, and it's real hard to figure out how this was dimensioned and how it was measured. I really don't know what was the design intent. I haven't seen a drawing. So you might remember I made this fixture, and that fixture matches the sphere on the bottom of the combustion chamber, but I cannot possibly make a reference here to measure it from the center of the sphere, you know, and without a fixture I can't practically do that. So what I decided to do, I decided to create a fixture that would help me to measure it. And the first iteration looked like this. So this is just, you can see just a piece of paper. So I just mocked it up. This is actually backwards. So this is the exhaust side. You can see that's the exhaust. And then this is the intake side. So that's the intake. So the idea was that I can cut a piece of aluminum with certain thickness and basically put it in here in some ways, and it would have holes here, 2 10mm holes, and I can use these pinholes to exactly position it in a proper manner. Now one of the issues was, is it gonna fit? So can I put it in this way? And you can see that it doesn't fit in. Can I put it in this way? It doesn't fit in either. You know, it gets locked. Can I go in from this side, maybe rotate it, and you can see that it locks up just about from every side. This is one of those issues if you are using CAD software where the CAD is not really much of a help. You know, you can create a path and you can move this along the path, but if the part has to move along the path and then tilt and then move along a different path, you know, that requires some knowledge to do, and also, you know, you have to do an analysis, and in each step of the analysis you have to do an interference check. So you can play with that forever, but you know how much time you have on your hands. So I decided to do this once I had a model that I thought will work, you know, with some finite dimensions on it. Then I can go and create a scale print, cut it out from paper, and see if it fits. And it didn't fit. So then I went back and I redesigned it, so I made it a lot skinnier, as you can see. So the same idea, this would have a specific thickness made out of aluminum, and then let's see if this case it can be inserted. And you can see that in this case, you know, it will go in relatively easy and it will fit in. So I went ahead and I 3D printed one, and there's just some blemishes here on a 3D printer, but nonetheless it tells the story. So this is the exhaust side, I put a marking there, and then this is the intake side. So as you can see from this side, it will go in nicely and it will go into position. So if I try it from the exhaust side, you can see that from the exhaust side it will lock in and it's not gonna go in. It just locks in, so I cannot possibly put it in. So it only goes in from one side. So once I had this, then I went ahead and I actually machined it from aluminum. So the part is 16.6 millimeters thick. So you can see I had this aluminum stock. It's plated on both sides, so the plating is not machined off, so it's just stock, some kind of plate. So I made this on a Bridgeport. I got an old Bridgeport mill, and it was especially hard to create these radiuses and these machined surfaces here, but nonetheless turned out nicely. So in first time I was trying to insert it in, it didn't go in, so I had to go and round these corners off. So now we can try it from the intake side, and you can see it nicely goes in. It locks in, so it doesn't come out just like that. Trying to see if it comes out through the, look at that, it comes out through the exhaust side. So maybe the plastic is not exactly the same size, the same shape. Maybe it's warped. It looks to be the same, although. So what do we got here? So if you look, this is the exhaust side, that's the intake side. So here's the intake, and here's the exhaust. So I'm just showing it with this cylinder head. The same story plays off with that one. So now if I insert these pins, I know exactly how these surfaces related to that pin. So what I did here is I took the center of that pin, and that surface is exactly 10 millimeters from the center line of the pin. So the same here. It's exactly 10 millimeters. But the most important thing is that now I know that this plane is parallel to this plane here. So this plane here and this plane are parallel. Same is true to this one. So this plane and that plane are parallel. So if it's assembled into this one, I can go and I can measure the depth precisely. Okay, I can take that measurement, and now I can reference this plane relative to that hole. So that was basically the purpose of the whole exercise. One of the other things that I did is I added two holes here. These are 5 millimeter reamed holes, and you can see once I assemble this into the cylinder head like so, you can see these pins nicely fit in. They are a little tight, especially if they go in crooked. So you can see I have this gauge pin, 4.99 millimeters, so 10 microns off of 5 millimeter. It goes in nicely into this hole, and then it will match with the hole in the cylinder head, so the the valve guide has the same size hole. It goes in on the exhaust side, and same thing on the intake side. Okay, so once I assemble this pin into the hole, then I know that it's absolutely in a correct position. So here's another pin. This is just the cutoff from the same drill rod, and you can see it goes in nicely. And this surface here, this cylindrical surface, mates well with the surface of the cylindrical surface of the valve guide. So now I can go and I can measure the depth and the different steps and the different surfaces there, and verify the plane location in every one of these cylinders, the cylinder heads. I don't have a CMM to measure this precisely, so this is my approach. This is how I did it. I'd say designing this part took half an hour. You know, 3D printing that was basically you just launch the printer, and when it's done you just remove it from the print tray, and then actually machining this part, I think it was 2 hours, maybe 3 hours on the Bridgeport. So it's considerable amount of time, but nonetheless, now I can have that reference exactly, and when I'm designing the engine, I have faith in my 3D model. Thank you guys for joining me today. Hope you learned something. Hope you enjoyed the video. If you like the video, please give me a thumbs up, and if you like the channel, please don't forget to subscribe. See you next time. Bye.